Alrighty, welcome back, everyone. We are back in section 12.2. We're looking at the second ANOVA testing, and we are looking at two factors, the age bracket and gender. So we have an age bracket in years, that's the number of rows, so 3 rows, 18 to 29, 30 to 49, 50 to 80, that represents 3 rows, and 2 columns, 2 factors, the female and male. So here are my 2 factors that I'm going to look at. We need to look at the interaction between the 2 factors. So we're going to look at the p-value. We are also going to be exploring the data. So here we actually have to look at the mean of each individual value. The sample means for the first row is 80.4, the second row 82.2, 80.4, and so on. So the way that we want to do it is we want to make sure that we know how to interpret the interaction as follows. The interaction, when we look at the means between the males and females, are parallel. Therefore, it does not appear to have no effect on one variable and the other. Now, what we're looking for is we want to use my sample categorized with 2 factors in a 2-way analysis of variance, and we're going to do that through StatDiff. And we're going to conduct the following 3 tests. We're going to look for an effect of the interaction. So we're going to look at the p-value for the interaction. We're going to look at the p-value from the row and the p-value from the column factor. So from that, we're going to look at the normality. So each of the cells shows a normal sample. So if you look at each of the rows of the values here, they do appear to have normal. They all have the same values. There's 10 values on each of the cells. There exists the variation, the sample variances, and the samples are simple random samples of quantitative data. They are independent of each other. This is a 2-way sample. They're categorized by the gender and the age, and there exists a balanced design. All of the cells have the same value of 10. Now, for this, we are going to need to find the F test statistic for all of them and finding the p-value for the interaction effect, the column effect, and the row effect. And we're going to look at each independent p-value. And remember, if p is less than alpha, less than or equal to alpha, we are going to reject the null. If p is greater than alpha, we are going to fail to reject. So let's get started on how to use StatDiff for this. So we're going to go to StatDiff. Let me go ahead and open my browser. So up here, we're going to select on StatDiff. So now that we're at StatDiff, we're going to go into analysis. We're going to go into 2-way analysis of variance. When we're here, how many rows do we have? We have 3 rows. Remember, the rows corresponds to the ages. So 18 to 29, 30 to 49, and 50 to 80. So 3 rows and 2 columns. Now, how many values are in each cell? There's 10. So that's going to generate a table. So you're going to have to input the 60 values that are listed. So let's look at the values that were given. So we'll start with 104. We're going to go horizontally. We're going to look at the rows first. 104, 82, 80, and so on. So then we're going to look over here. I already listed all of the values. You're going to do that. 104, 82, 80, 78, 80, 84. Now look, row 1, column 2. You're going to have now 72, 64, 72, 64. This is the data that we're given in slide number 4. So now that we have all of the values inputted, I have all of the 60 values that are listed, making sure that I'm rechecking and looking over exactly the correct value. You have to check that everything's correct. I'm going to select evaluate, and then it's going to give me these results. So notice that I have interaction, row variable, and column variable. Those are the 3 things that I have to test. So I'm going to look at the p-value for each individually. So I'm just going to hit on download. So I'm going to download my results from StatDiff, and I'm going to open them. So I'm looking at here the interaction. I'm looking at the p-value of each. So if I look at the interaction, my interaction is 0.39729. So that p-value is greater than or equal to alpha. My significance level was 0.05. So since my significance level was 0.05, I can already say, I'm going to annotate it. Let me annotate here. And I don't think it's showing me. Let me share this screen. So this is the screen that I want everyone to see. So here's my p-value again. Let me annotate it. So here is my pencil. I'm going to draw it. I'm going to kind of circle it. So that p-value right there is the p-value for the interaction. So let me highlight that instead. Yeah, so the interaction has this p-value. This p-value is greater than alpha. So what does that mean for us? So for this one, I'm going to fail to reject. So that's for the interaction. Now I'm going to go into the row variable. Now I'm going to use a different color. So now I'm looking at the row variable that has a p-value of 0.172. That is also greater than alpha. So that is also, I'm also going to fail to reject both of them because both of these p-values are greater than alpha. Now the last one, which is a column, so let's use the green. Now the column variable has a p-value, right? It has a p-value of 0.005, which is less than alpha. So the last one, we are going to reject the null. And they all have different f values. So I'm going to stop annotating. And then I'm going to look at my values here. I'm going to make it smaller. And then I want to make sure that, look at the F value. The F value, there's our test statistic, there's our critical F, and there's our P value. So here's our P value right here. And this is our MS value and our F value. So we can find everything that we want here. Let me go back and share my other screen, my desktop. Let's see. So there's my stat disk. And here I'm looking at my test statistic of F for each of the interaction, my F test statistic for my row, and my F test statistic for my column. So you don't have to calculate this by hand. The good thing is that once we are able to input all of the values, we are able to kind of generalize everything. So make sure you download it so then you can see that last column of your P-score values. So with that, you're going to go back to the notes, which is going to reflect everything that we just did right now through StatDiff. So then going back to finalizing our results, we notice that based on each of them, the interaction, we had the fail to reject, the p-value was large, so we failed to reject the null. That means there's no interactions between the two factors. We conclude that there's no interaction effect. That would be the first answer for the interaction because the p-value was greater than alpha. We failed to reject the row and the column. So the row effect, we did fail to reject. So if the p-value, we noticed that the p-value was greater than alpha, we failed to reject. That means we conclude that there's no effect from the row factor. However, the last part, the column factor, we did reject the null. So if we reject the null, we conclude that there is actually an effect from the column factor. So then based on that result, what can we conclude? You can also find the variance of each of, we can look at the pulse rates of each of the sections. So then here we can find the variance of each. That is the procedure of the two-way analysis of variance. So the same way we did for the mean, we are going to do variance. So we can do that aside. So we can go back to the data that we're given for the initial. So each row will have its own variance, its own sample variance. So we would have a variance for the first row, first column, second row, second column. so on and so forth. The way that we calculated the means like this, we will also be calculating variance. That's what that slide is saying. So going back to our example, the only one that we noticed is given the pulse rates from the earlier, we used the 2 analysis of variance. We did that through StatDis. We noticed that there was not an interaction effect, there was not a row factor, but there was a column factor, and that's when we rejected the null using a 0.05. We found the variances of the cells, the sample variances from each to be 100.3, 51.7, 103.5, 183.2, 138.5, and 293.5. Notice that they all differ considerably. So this means that they don't have equal variances. So then we notice that the samples are simple random subjects. Now the samples are independent from each other. They're not matched in any way. They're independent. So all of the requirements are satisfied. So looking at the solutions in general, we notice the F-test statistic for each of them individually. So we found the interaction effect has an F-test statistic of 0.391, and we saw that in StatDis. So going back to StatDis, it's looking at the interaction, and there is our test stat F, which is 0.93905. The row variable will have an F-test statistic of 1.81, and our column F statistic will have a value of 13.59. So all of those values are calculated by hand on our slides, but you will not have to do that because the F value is already given. So we found that there is no interaction effect. We also noticed that because the p-value was greater than alpha, we already know that. Same thing with the row. The row there's no effects from the row factor and there's no effects from the column factor. So those will be our null hypotheses for testing the rows and the columns. So when we're looking at the null hypotheses of there's no effect from the row column, we will fail to reject because we identified that the F-test statistic is 1.81, we know that, and our p-value is also greater than alpha. That means we will fail to reject the null hypotheses, that is, that the pulse rates do not appear to be affected by the age bracket. Now the last piece, when we find the column factor, we found our F-test statistic, which was 13.59, and that matches to what we found on StatDis. And the p-value was 0.001, or in that case, when we used StatDis, it was 0.005, which is still less than alpha. Now, when it's less than alpha, we reject the null. When we reject the null, that means that the pulse rates do appear to be affected by gender. So that is the only one that is having an effect since we rejected the null. And the interpretation, how we finalize the section 12.2, is that on basis of the sample data, we conclude that the pulse rates do appear to be affected by gender, but not on the age bracket, because the only rejection of null that we had was through the column factor, and the columns were based on gender, not based on age. So if it was the other way around, if it was a row that we rejected, then it would be the age bracket, or it could have been both. So at the end of the day, it does depend on the p-value that both the row factor and the column factor appears to show, and of course the interaction. And with that, we conclude section 12.2, and that finalizes our lecture notes for this entire semester. I do want to point out that there is going to be a chapter 12 test. So please make sure that you are practicing using StatDis. If you want to use your TI-83, TI-84 calculator to do that, I will be placing links for that on your modules, but I will highly encourage you to use StatDis. That way that will facilitate your calculations for sure. Thank you, and I'll see you guys next time. Bye-bye.